Welcome to the VHDL Design and Modeling of Digital Systems course, Design Units. A design file contains one or more design units. However, a design unit cannot be spread across multiple design files. A design unit consists of a context clause followed by a library unit. A context clause consists of one or more context items, either implicitly or explicitly. A context item consists of a library clause followed by a use clause. It is used to name one or more libraries and make library units, like packages within those libraries, visible through the library unit that immediately follows. The syntax is as follows: a keyword library, followed by a library name list, separated by commas if there's more than one. The next line is the use statement, which is use, then library name dot package name dot all. The library statement or statements are used to specify which libraries are to be used by subsequent use statements. The use statements are used to specify which portions of the library units are to be used during elaboration of the subsequent library unit. The following example specifies all of the IEEE library package std_logic_1164 is available for reference during the elaboration of the subsequent library unit. Note that the .all keyword makes everything within that package visible. Each design unit is elaborated as if the following context item were present, i.e., an implicit context item: library std and library work. The use statement that follows says that use std, package std, or library std, and package standard, and use all of that. The std library contains all of the predefined data types of the VHDL language. The library work is the default library that all design units that have been elaborated thus far are placed into. A library unit consists of a primary unit, a declaration of an entity, configuration, or package, or a secondary unit, like a body of an architecture or a package. A primary unit is not dependent on other design units. However, a secondary unit depends on a primary design unit, which is to say that no secondary unit can exist without a primary unit. The context clause of a primary unit applies to all of the primary units corresponding secondary units. Architectures and package bodies are the secondary units. Subprograms are not library units and must be inside entities, architectures, or packages. The analysis, compilation of a design unit results in a library unit in some design library. Predefined libraries typically include, but are not limited to, std, IEEE, and work. Work, as we said before, is the default user library. The entity is basically how we look to the outside world, what our inputs and outputs are, perhaps some generic things that we might associate with the instantiation of this particular entity. Also allows us to do a couple other things. Let's go chew into the syntax. The entity declaration is a primary design unit whose syntax is as you see here. We have entity identifier, basically the entity's name, followed by a port list. A port list defines the port connection possible with this entity and its mode. The mode of a port signals can be in, out, buffer, or in-out for like bidirectional. The generic list is used to define the generics that can be changed when the entity is instantiated. Each generic has a default value that persists if the generic value is not changed when the entity is instantiated. The declarative items can be the same declarative items as declared in a architecture body. Declaring them here in the entity will associate them with any corresponding architecture body. The optional passive process here, which is seldom used but it's part of the language syntax, can be used to monitor use and operation of the entity. The passive aspect of the process means that it may or it may not affect the operation of the entity. We'll discuss processes themselves at length when we hit session 5. Here's an example of an entity statement or declaration. The name of the entity is HalfAdder. It has inputs and outputs. The port list here is shown as 2 inputs, A and B, of type bit, and 2 outputs of type bit, C and carry. The entity itself contains no description of how the function is performed, merely of that of the port definition, the inputs and outputs. The architecture declaration contains the description of how the function is performed. Each architecture body refers to a binding entity. There must exist one or more architecture body per entity. Each architecture defines how the functionality is performed and could be used to differentiate between different technology specific implementations. When we instantiate a component, we can specify which exact binding we're looking for, which entity architecture binding as well. Here's the syntax for the architecture declaration. The architecture keyword followed by the architecture name identifier of, and then an associated entity name is, and then we could have one or more or 0 block declarative items such as constant definitions or declarations rather, signal names, followed by a begin statement and then concurrent statements, followed by an end, optionally the keyword architecture and the name of the architecture. The architecture declaration references the matching entity. It also describes how the outputs are derived from the inputs. Here's an example. Architecture declaration. Architecture arch1 of HalfAdder. HalfAdder, as you recall, is the name of our entity. Arch1 is the name of this particular architecture. In theory, we can have arch2, arch3, call them whatever you want. You can specify unique identifiers there. There are 2 concurrent signal assignments, and we'll get into those a little bit later. But briefly, the first one is C is basically derived from XORing A and B, and carry is derived from ANDing A and B. Very often we will want to instantiate other components within a specific architecture. Before we can instantiate it, we need to define what it looks like. and that's where component declaration comes in. Here's the syntax of a component declaration. Component and then identifier followed by a port list and a generic list followed by the end statement and component identifier. The component declaration is made with the declarative part of an architecture whose syntax is very similar to that of the entity. Here's an example of our HalfAdder if we were going to use it within another architecture. We were going to instantiate it in this one. It's the similar syntax as before, component HalfAdder, which is the name of the entity, and then our port definitions, the 2 input ports, the 2 output ports. We'll cover component instantiation a bit later.